All right. Welcome back, everyone. Before I hand over to my co-chair, Diego, to open the Rump session officially, I have to make one very, very important announcement. We have just been told by the general chair that outside there's all kinds of signs saying that you're not allowed to drink in this room. So please enjoy the Rump session.
Hi, everyone. I hope people online can hear us. If there is someone online, can you please scream until you can hear us? Internet people, can you say something?
We can hear you.
Yes.
I heard a yes. I don't know if it was someone impersonating the internet people. I hope not. So last year, I co-chaired the Rump session with Yuval Yaron, and Yuval asked me to share bits of wisdom with the chess community. So I'm doing the same. So I will share some bits of wisdom. I hope you appreciate what I'm about to share. So first I need to figure out how to, So this is the cryptography multiverse, right? You have the trunk in the middle, which is like mainstream cryptography research. And then something happens in time where a new timeline is born, right? You have the TCC one, the chess one, FSC, and so on. There might be even a new one for the new journal, right? We branch in timelines all the time, but this actually creates tension, right? As these timelines diverge and they fragment the community, there's tension between these timelines, and that can create hostility. Timelines can become hostile against each other, and that's not a good thing. So one recent incursion of the chess sub-community to the theoretical cryptography community was chess people submitting papers to Eurocrypt, and it seems we did quite well. We had the highest acceptance rate at Eurocrypt. Let's celebrate that. That's Or Dunkelman there. This image is used without permission. And this talks about the multiverse, right? Last time I gave this talk, we were like, oh, are you talking about the metaverse? No, it's not this NFT crap. It's not about apes. If there is someone from ABC Mint here, by the way, Matthias is here too. You owe him money. Please pay. And it's not about this metaverse crap as well, right? It's, if you work at Facebook, I'm sorry, your life must be very sad. Now to the serious part. So there's some fascinating applied crypto research being done, or crypto engineering research being done out there. And we in particular think that zero knowledge proofs and MPC research is not being properly represented at chess. So together with Marcel, we decided to extend the CFP for next year. You probably have seen this in the website already, to include 2 new topics, which is exactly engineering of zero knowledge proof systems and also privacy preserving computation in general. We received already enough, not enough, it's never enough, right? Some FAG papers, but we also want MPC papers. And we need the community to contribute such that one particular said future never happens. So we don't want one particular feature to happen, which is like this one. So we want many privacy preserving computation papers on chess, especially the crypto engineering aspects of that. If you want to submit, talk to us, talk to me and Marcel, send us an email if you have questions. So now to the Rump session program. I'm absolutely appalled to announce that we received 17 submissions, which is nice, a prime number. 1 had to be withdrawn because of censorship. One submission was withdrawn because of censorship. It was a top-level management order. We cannot talk much about it because we receive a gag order at the same time. It's like, I think this will change Rump sessions forever, and we need to make a stand, a protest against censorship. So we got 16, still fine, power of 2. As co-chairs, we shortlist candidates for you to decide on the Rump Session Award, also called RSA. And then Peter had an adventure today. He went out to buy RSA, and actually it's somewhere here. I don't know exactly what it is, but he told me it's down here. And one thing for sure is it was cheaper than the 10 million that the NSA paid to buy RSA and backdoor their crypto library.
Not much though.
So you get to decide or you get to vote, but at the end we decide who wins anyways, right? But voting is important, democracy is important. This is the Rump Session program. So we start with the serious stuff, the chair's report, that's Tonya. And then we go to announcements, right? And then we have a break, a 20-minute break, it seems, for you to maybe refuel and recharge. And then we have some amusing talks, some two important logistic information. Time limits will be enforced. So we actually do our best to move you away of the stage if you take too much time. The other thing is, if you submitted a talk and was accepted, by the way, if you were not, a victim of censorship, I should also, if you want to protest against censorship, talk to Benedict. He's responsible for that. So pay attention to the program and come near the stage such that we can have like a smooth pipeline of speakers going through. Now I give the word to Tonya to share the report.
Are you recording this?
Yeah, hi. So we would like to give a short report on how the program, about the chess program and how it came to be. And as it goes with conferences and transactions, it usually starts with good research, which then is written up at some point and submitted, being reviewed, and then finally presented at a conference. So with chess, you have 4 opportunities per year to submit your papers. If you do so, you will be reviewed by 4 peers that are experts in their field. They will take about 2 months to review and discuss your work. In the middle, you have a chance to interact and actually look at the reviews and clarify misunderstandings in the rebuttal phase. So far, so good. A few things we tried to do differently this time. We included an appendix, the appendix in the reviewing process, making sure it gets reviewed. And we also introduced a PC meeting towards the end of the reviewing phase to foster discussions and actually, papers that were where there was discussion going on and there was contentious discussions, so to come to a good decision in the end. And about 18% of the papers went through this process. So I think that was quite a nice change. In total, we got 283 submissions that resulted in a total of 1,200 reviews. Most of those reviews were completed by the members of our program committee, consisting of 66 people. And in addition, we had about 83 external reviews from other experts in the field. And as we are a deadline-driven community, you all know that if you submit it, usually the number of submissions spikes towards the end of the deadline. The same is also true for the reviews, which need to be ready in time before the rebuttal phase. And we see the same behavior there, right? So we see a nice spike. And of course, there are a lot more interesting statistics.
Yeah. So Thomas and I worked very hard on building a nice, great program committee. So for that, we tried to balance it according to different aspects. And some of them are displayed here. So we tried to balance the gender. Of course, we cannot achieve half-half, but we tried. We also tried to balance the affiliation between academia, industry, and government. And we also tried to balance the country, like the continent where the PC members came from, between Europe, Asia, and Americas. Something which is not displayed on this slide is we also try to have fresh blood, namely new people in the committee with absolutely no IRCR-PC experience. And so we had 27% of fresh blood in our program committee. And we are very happy with that because they did a great job and they did, nice reviews, and we are super happy that we had them. Now some statistics, as usual, on the submitted and accepted papers. So here you can see the submitted and accepted papers for the past 20 years. So the number of submission is growing, especially since 2018. Now we are in journal mode. And of course, the number of accepted papers is growing as well, because we have quite a constant acceptance rate. If you submitted to chess last year or this year, You probably know that when you submit a paper, the program committee is working very hard on it, and then the reviewers converge towards one of these 5 decisions. So either your paper is accepted, either it's a minor revision, meaning that you are followed by your shepherd for 1 month to improve your work. All of them were finally accepted. Either you receive a major revision decision, meaning that you have a list of criteria, a list of improvements from the reviewers, and you can resubmit your paper with these improvements done to be accepted. You can also get a reject decision with encouragement to resubmit, meaning that the reviewers decided that your paper is not ready yet, but has potential. Of course, you can be rejected as well. So here are the statistics for these 5 decisions per issue. Now, the statistics of submitted and accepted papers per category. So you can see that, of course, a reasonable observation is to see that the paper which got a major revision decision have a much higher acceptance rate than the regular paper. So the regular paper, you have 29% acceptance rate, and the major revision paper, it grows to 80%, which means that I want to believe that the job made by the authors and the reviewers is important to increase this number. Also, if you have a paper which got rejected with encouragement to resubmit, you also have a higher acceptance rate, probably because of also the work of the authors and the reviewers. And now a paradoxal observation is that if you submit a long paper, you also have a higher acceptance rate, which is paradoxal because personally, when I receive a long paper, I'm not super happy. I prefer reviewing regular shorter papers. But so my intuition, my guess would be that the reviewer, they want to make sure that they won't review your paper again. And so just my intuition. A last graph, maybe my favorite one, the number of submitted and accepted papers according to the number of authors per paper. So a stupid advice that I can give you here is that don't submit a paper with 9 authors. Go in the streets, ask your husband, your wife, your kid to co-sign the paper, because you will multiply your chance to be accepted by 4. But don't go over that number, because otherwise it's got down to 0, right? Be careful.
All right, that brings us to the program, which you have already enjoyed for a day now. So we accepted a total of 83 papers. Most of them are presented in double-track fashion. There's only a few presentations that are an exception to that. So one will be the best paper, which will be presented on Wednesday in single track. And then there are the 2 invited talks. One was already given today by Dominic Rizzo, and the other one will be given tomorrow by Martin Albrecht. Besides that, we had some other components in the program as well. The tutorials and the taser workshop, which happened on Sunday. And we also have the continuously ongoing poster sessions. So if you haven't used the chance to look at the posters and to talk to the authors, yeah, make sure you grab a chance at some point. They are actually shown outside the lecturing halls. So please, yeah, use that chance. One other thing we would like to point out is the artifact evaluation, which we have had for the last 2 years, and it continues on. So if you are publishing, if you have a paper accepted at CHESS, you have the opportunity to submit artifacts such as code or data sets to be reviewed and then included with on the website with the paper, basically. And please consider that, because it helps increase reproducibility. At the moment, it's voluntary, but definitely it's also encouraged. And as it's an important point, Peter will talk a bit more about it in a moment, right? So, so overall, we hope you enjoy the program. So there were many people working very hard to get it ready for this conference. Of course, there's the program committee and the external reviewers who invested a lot of time in the reviews. There's the managing editor, Tim, and with the support of Marcus, and our web chairs, Peter and Ruben, the tutorial speaker who made it possible to access the work. There's the tutorial speakers, poster chairs, and session chairs who have been helping out throughout the conference, the artifact and evaluation committee, and most importantly, of course, the people who actually produced the work, the authors, and the people who actually presented in nice presentations throughout the conference, the speakers. So yeah, let's thank them, right?
All right, as already announced, I have the honor of talking about the T-Chess artifact evaluation. Should say that really it should be Martin standing here, but Martin can't be at chess, well, at least not today. So I have been volunteered to give this talk. And I thought, well, if I give this talk, I would start with a short review of the rich history of the chess artifact evaluation, which basically means that it started all in 2021. And I must say that Douglas Sibila did an amazing job at actually establishing all of this. It continued in 2022 with Martin Albrecht, who should be standing here. And it will be continuing in 2023 with me probably again standing in front and giving this talk. By the way, if you're wondering how you're becoming artifact chair, basically works as follows, at least from my limited experience, I can speak here. You get invited to become a PC member. And then at some point you receive a message from the PC chairs telling you that you're uninvited to be a PC member, but that the job of artifact evaluation chair would still be available. So here I am. Thanks, Diego. Thanks, Diego. Yeah. Now, given that this history is rather young, some people here may actually not be super familiar with the concept yet. So I thought it probably makes sense to at least say a little bit about what this whole thing is. So the idea is that authors of accepted papers at T-Chess are invited to submit artifacts, which could be software or hardware implementations, could be data sets, but could be all kinds of things that basically add value to the paper. The goal of the artifact evaluation process is then to ensure that these artifacts are functional, for example, that software compiles and runs, and that it's reusable. So for example, that there's a proper README, that the code is commented, that you might be able to easily modify it. We're not trying to actually go into reproducing the scientific results that are presented in the paper. So we're helping reproducibility with this, of course, by making sure that at least it runs, but we're not looking into actually reproducing the results. How is this done? Well, there's a hotcrap instance, so you can just submit your artifact on hotcrap, and these artifacts, well, need to include, of course, the actual code or data. They also need to include a README and a license file. And then, so the artifacts themselves, they're non-anonymous because we know anyway who wrote the paper, because that's already published on the T-Chess website or the list of accepted papers. And then they receive 3 anonymous reviews. So the reviews remain anonymous. And usually after the reviews, there's an interactive process of improving the artifact. So usually one of the reviewers, at least on their system, was not able to build it or run it, or the output was not as expected or something. And then possibly there's a shepherd being assigned, and the shepherd then, well, helps improve the artifact. The goal is essentially to accept all artifacts that, at least, well, bring them to a point that they're functional and reusable, and then accept them. And once they are at that state, they get archived at artifacts.iscr.org. That's the website that was also well, introduced with this process in 2021. And then you get a link from the paper to that artifact from tchess.iscr.org. So there's a lot of being said about evaluation criteria on a website. Actually, this is the website. So if you want to read all the details, go through that. But essentially, the idea behind it is, imagine you're a student in a couple of years, say 2029, first-year grad student who's told by their advisor, so just take this artifact from Chess 2022 and just do something with it, change it to do X. And what we want is that the student has the best chance of success and the least amount of pain. And that's also why often in the artifact evaluation committee, there's a lot of young researchers, there's PhD students, there's postdocs, because those are the people who would go through the pain usually of making these things work if they're not properly written. And it's also, I think, a very nice way for young people in the community to get involved in the chess reviewing process. Now, as an author, you might feel like, why would I do this, right? So my paper's already accepted. So why would I spend additional effort, more time on an artifact? Well, it's essentially two answers to this. One is it's a service to the community. I mean, there's many people, we already got quite a bit of round of applause, but you can do it again for all of the people sitting here in the front, really doing all of this work here to run chess locally. But making your software available, making your hardware available, making sure that it's still available in a couple of years, that it still runs in a couple of years, makes the scientific aspect of our community so much more rich and valuable and helps people actually contribute to this community. But you might ask, okay, but what's in it for me? And it turns out that it really increases the relevance of your paper and of your results. So for example, it increases your visibility by up to 72%. It also brings up your citation count to up by 43% if you submit an artifact. You get more future collaborations from this. So it goes up to about 2.3 collaborations if you submit an artifact. And you get more future funding. So it's around 50K per artifact that you will get in future funding. As you may have noticed, these numbers are completely made up, right? But really, I think it does really help, and it does really improve the value of your paper and the visibility. So with this, I would like to actually thank the Artifact Evaluation Committee for 2022. There's a lot of people who did an absolutely amazing job at evaluating these artifacts, except for this one guy, Peter Schwabe. He's still shepherding a paper from issue 3, and he's super slow and shouldn't be re-invited to the committee. It's really terrible. But aside from that, amazing job. And maybe you can also give these people a round of applause. Now, you've seen already lots of statistics. The statistics are very simple for artifacts. They were all accepted. There's maybe one thing that is noticeable about the slide still. For issue 2, there was only one submitted artifact. That might be just a statistic outlier, or maybe advertisement went wrong or something. We don't know. It was just one. But in a sum, we got more than 30% of the Chess 2022 papers. They come with artifacts. I think this is pretty cool. Well, but you could also say those are rookie numbers, right? So for 2023, when I'm sharing this, let's get these numbers up and please submit your artifacts. And if you have a paper already accepted in issue 1 of T-Chess 2023, the deadline is October 28th. Thank you for your attention.
Good evening. My name is Mathieu Rivin. Sorry, I won't be doing a funny talk at this one. At least if it's funny, it's not on purpose. Just a short announcement that we are looking for organizers for the next edition of the Chess Challenge. So as you might know, we have a challenge associated to chess since 2015, but not this year, which is unfortunate. So we'll have a lot of expectation for the challenge of the next year. So we welcome any proposal of challenge organization. So it should be related to chess topic. It should target the chess audience. And that's about it. So you can find all the information on this web page on the Chess 2023 website. And yeah, that's it for me. Enjoy the Rump Session.
And I'm back, but this is actually a remote talk. So I think we may need a little bit of tech support now. Abdullah, you should be sharing your screen, but maybe we should be unsharing it. And I don't know, I don't have the power here. So there's only one remote talk. We need to do this only once at the very beginning now.
Can you guys hear me?
We can hear you.
Okay. Okay, let me know when I can start.
Please go ahead.
Okay. So hello, everyone. I'm Abdullah. Today, we're going to talk about solving the cold start problem for reading research papers with Ask Crypto. So I don't know if you remember, in Eurocrypt 2021, I made another Rump Session talk titled The Cold Start Problem for Reading Research Papers. And basically today we're going to talk about solving this problem. But before, a small reminder about what the problem was. So this is the journey of a person who is reading a paper, and naturally there are questions. And when we have questions, we try to ask the authors or some other people that we know. And this interaction is usually private, and no other people can benefit from it usually. You can argue that this does not necessarily occur in private. You can also ask it on Twitter, but public does not necessarily mean easily locatable. So these are also not very convenient for other people to find later. And this is for a single paper, so that's why it is called the cold start problem. It basically says, whenever you're reading a paper, it's as if you're reading it, you're the first person who's reading it in the world. And when you go to the references, this basically blows up exponentially. And what I proposed last time was to pre-compute, construct lookup tables, and make them publicly available. This is a direct analogy to a naive solution for an exponential size problem. And basically, since that talk, I tried to execute the solution, and now we have Ask Cryptography. It's a non-commercial platform to basically discuss and ask questions about papers on ePrint Cryptology Archive. And let's see how it works. So first thing we need to have is we need to have a single page per paper, because for making things easily accessible, we need good indexing. And luckily, we already have that index. It's the ePrint Cryptology Archive. And the indexing is actually very simple. It's just a year and a sequence number. So we do the same. We have a single page per paper. And not only that, the URLs are almost identical. You just change the root domain, and then you land on the main page. So what's on the main page for a paper? You see some basic information on the top, and in the bottom, you can see all the topics about this paper so far. Note that this is not simply attaching a comment section to papers. There's a organized way of doing this, and there are different topics, and you can basically click to them and then expand. So what kind of topics we have? We have three of them. First, resource. This basically includes some metadata, and then other people can basically post any kind of resource about this paper. For instance, like chess is a good audience for this because artifacts are motivated. And for IACR conferences, if available, talks and slides are automatically added to these resources. Then we also have questions and discussions. These are self-explanatory, but the important thing is that all topics are related to at least one paper. If your question is not related to a paper, but it is still related to cryptography, there are already very good platforms for doing this. What this platform aims is that to collect the questions about papers and make them stick to the paper so that other people can locate them easily. All right, so this is for like a reading experience. What do we have for authors? You can basically become a verified author if you have any paper on ePrint, and there are some functionalities for them. For instance, your usernames are displayed on related topics to your papers, so that whenever you post, people will know that you are the person who is the author. Secondly, maybe more importantly, you can choose to receive automatic notifications about new topics on your papers. And lastly, this is new. I just enabled this feature just before this talk. There's now a My Papers dropdown where you can quickly access your papers, search through them, and go through the main pages easily. Okay, some stats. The platform was publicly announced in 22nd of August, so we're 3 days short of a month. We currently have 178 users. 47 of those are verified authors. And there has been 10 questions so far, and 6 of them were already answered, and I'm pretty sure the rest will be answered as well. So that's it from my slide. The takeaway is that the platform is there now. It is functioning as intended, and the more you use it, the more it will be useful. So if you have questions about papers that you read, just bring them all to Ask Crypto. Thanks.
All right, thank you very much. Okay, Colin, are you here? You're behind me. That's great. All right, the floor is yours.
All right. Thanks very much. So before I begin, I have an even less funny quick story. I have to thank Pankaj. It sort of seems fitting with the Test of Time Award. About 10 or so years ago, I forget exactly now, there was the Ches Challenge. You could get this Acebo board. If you email them and you say, like, please, I would like this board to do some fun stuff. So I was one of the recipients of this as Colin, unknown guy who claims to be doing a PhD at the time. And you can see that board in some of the original Chip Whisperer papers. So I have to say thank you. You know, the Test of Time, it's not only a testament to the work then, but what happened later. So unrelated, but so here I am to talk to you. Before the last Ches event in person, I had some discussions on post-quantum crypto. And what I saw is the most important thing about post-quantum, that there is other problems like time travel could exist and other things could exist. So then I said, okay, what if I indulge you? What if I accept these people that claim a post-quantum computer could exist one day, maybe? And if we look at the story is always very simple. There will be a post-quantum computer, but don't worry, we will solve the post-quantum problem and the world will be fine. But is that what will happen if we have them and we accept this? We say, well, okay, RSA is broken, all of the internet banking is broken, everyone can steal money from everyone, right? The world will not look like a nice world with post-quantum enabled, right? It looks something like this world. And so my question is post-quantum crypto actually targeting a post-quantum world? And are these constructions relevant for a post-quantum world? So I thought I would do a very short survey of the proposals around post-quantum and how they apply to the post-quantum world we might see. Okay, so I picked a few. I didn't have much time to look into it, I admit, so correct me later if they're wrong. Oil and vinegar signature scheme. So this one I think will be very relevant because if we think about the post-quantum world, if we look on some verified websites like YouTube, we find some very interesting things about how oil can be turned into a flamethrower. So I think this is immediately, yes, this is a check mark for post-quantum. So we are good. Another popular proposal is around lattice-based post-quantum crypto. So this one, if we consider the structure of lattice and the strength it gives us, we can see that there is actually really good applications for lattice-based systems in a true post-quantum world, because the strength you need in this sort of cow catcher is critical, right? And the lattice provides this sort of strength to you. The final one I very quickly analyzed was sort of a sponge-based thing. And you might think the sponge-based immediately lends itself to this sort of post-quantum world because you notice everyone's quite dirty. So you expect they would need like sponge baths type things. But you are forgetting a post-quantum world. No, because there is no water in this post-quantum world. We have ruined the resources, it is stolen. And so the sponge-based is written off immediately. So yeah, in quick conclusions, right? These constraints have been dreamed up by the cryptographers, the future world. And we didn't let the wolf guard the hen house. They designed the hen house, right? That's insanity. So I implore you, the Ches community, we need to spend more time applying these post-quantum algorithms to a true post-quantum world. Thank you.
Okay. Good evening. I'm Dongjun Park. Unfortunately, I need this huge script book because I'm not familiar with English. Please understand me. This is my first time at Chess, and I'm glad to stand here in front of you. I'm going to talk about the DNN accelerator and its challenges in terms of side channels. Everybody knows what a DNN does, even though nobody knows how it works. Since training on a great DNN needs a huge effort, the structure of the network and the exact value of parameters should be kept secret. However, in the real world, there are too many bad guys trying to steal variable DNN models from accelerators. Do you know, guys? Do you guys know here? They use something special, equations developed by experts in the AI field. And in a recent decade, they utilize also side channel and fault injection attacks as well. Another kind of bad act is to derive misclassification. Last night, I took a hot shower without noticing the door was open. What happened next? Please raise your hand. Yes, the smoke detector went off due to the steam. Lesson learned, you should book a large and expensive room if you want to take a long shower. This might be an example of misclassification, right? Look at the lizard. Look at the lizard that shows a lot of papers saying, yes, we could steal your models. Please notice that I'm not saying these authors are bad guys. I absolutely respect them. It's hard to defend against all the attacks, but we should do our best. Security experts, including you, are willing to do the most difficult works because they are difficult, not easy, don't you? Sorry for the strange letters, but I want to show you these beautiful Korean letters for no reason. This is the blueprint of our ongoing project granted by the IITP. Yes, they paid for me. When a DN accelerator is provided, our magic system will automatically evaluate the side channel leakage. Only the protected implementation shall pass the assessment system. Thank you for listening.
Elif, you're up next. Schnell, schnell, schnell.
Okay, so I want to announce an upcoming event in beautiful Passau, this very nice city that you see there. Who heard about Crossfire before? A lot of people, that's great. So we know the acronym very well actually, but I myself, like organizer of this year, I forget what it stands for sometimes. It's cryptography, robustness, and probably secure schemes for female young researchers. So it's a workshop on this topic. So we are having this this year in Passau. I'm organizing with Juliane Kremer from Regensburg. So we are not officially accepting any submissions anymore, but you're more than welcome to register. The registration is still running until end of this week. If you have questions, please let me know. Always giving a disclaimer, we're not actually discriminating any males or any diverse community. So actually we have male submitters as well. So you can just come and join independent of your gender. Thank you.
Thank you. You can just push the space bar. The next talk is also yours. Next talk is also yours. You can just push the space bar. Then don't need to get up.
So again, me, but together with Michael Pehl from Technical University of Munich.
So she said I have to say something. Well, you know the situation, yes. It's 15th October, class deadline is over, and you don't know what to do and where to push your PhD students, huh? And that's the situation. We want to help you out. And so we set the deadline for the crusade in Munich next year, to 28th of November for the moment. So that will be in Munich.
Beautiful Munich. I mean, it's not just Passau, but Munich is also great.
So I could tell you many things, I think, why to go there, but there are many people here in the room just coming from Munich. So just maybe show up who is from Munich.
Wait. Don't be shy.
So you see, if there are sufficient people, just go to them, ask them why to go to Munich.
Yeah, and there may be also a spring beer fest around that time, so maybe you catch.
At least there will be some beer.
There will definitely be a lot of.
Definitely. Okay. So maybe even strong beer.
Oh yes. Thank you.
Thank you.
So
I have a friend by the name of Peter Schwab. And yesterday he approached me and said, I'm really short of Rump Session talks. Give me something funny. Or maybe he didn't actually say that, but
pretty much.
And I said, okay, I'll come up with something. And this is what I'm giving him and what I'm giving you guys. For those who are at all interested in those things like, MPC, FAGE, and all that, you will love Asia Crypt 2022. And it's going to be in Taipei. I mean, we have some of the best places. We have very nice food. And one of my employees wants to make this announcement. When I took one of my friends out for seafood, like a shrimp actually leapt off the plate, trying to get away. Actually, maybe not necessarily always the best food, but I would say on average, we have the best safe food. And if you are into hiking, we have some of the best hills to climb. So please, those who like Taiwan, come to Asia Crypt. And if you don't like Taiwan, you will like it after you come.
Thank you very much. And maybe just before the break, let me add to this brilliant talk that also you'll be allowed to drink during the Rump Session. So with this, we go for a break, I would say until 1:15, so that really everybody has enough time to get enough drinks. And then we restart with the second half.
Before you leave, I didn't see you brought the glasses and the bottles inside. It's not allowed. Please let me not see them lie here after you leave. Otherwise, I have to go and pick them up. You don't want this to do it for me, right? Don't leave anything here which should not belong here. Thank you.
Yeah, I'm just. Hey, Thomas. Hi.
Yeah.
So I need the browser for the live thing.
Yeah.
And Peter mentioned that we can quickly check.
Yeah. So we have Firefox here. It's
Yeah,
that okay?
it doesn't matter.
Okay, so
it's crypt.
wait.
So crypt, like crypt minus gen.com, and then port 1337.
Like this. Okay.
I think we probably have to zoom in a bit.
Oh yeah, to make it readable.
Sharing?
It's not sharing.
Okay, perfect. Because the
I think the microphones are still on though.
the server will probably break down if if something sees
Is it? I'm trying to.
So you can the
It's completely like.
I hope so, right? He pretended really well.
Nigel is not in charge of everything.
So
He really doesn't give a fuck about it.
I know.
The best thing is, so Oswetner said, you know, at least don't drink alcohol. Look up the it's like this is my group, right? I'm doing something right. So Falk has the badge saying NPI is, so somebody looked at it and said, oh, it was Peter's group. He said, I think my PhD was Christoph Park. I was like, all right. Welcome back, everyone, to the second half of the Rump session of Chess 2022. It was a short moment until everybody found a seat and hit their drinks. And all right, not silent, perfect. And now it's my pleasure to hand over the floor to our first speaker of the second half, Thomas Böppelmann.
Thank you. So yeah, the title of this talk will be Crypto AI, and I would like to take you on a journey I took. So this is my AI journey as a hardware engineer. It was end of 2021. So this is all outdated by AI standards. Yeah, it's 1 year old, basically completely outdated, but there was the COVID lockdown. And then we thought that the NIST competition was about to end. And I was thinking, okay, NIST competition is ending, New Hope is getting kicked out. I need a new skill. I need to get into something new. Yeah? I cannot continue with this post-quantum stuff. And then everybody's talking about AI. Okay, so what do? Somehow I have to get into this topic. So I played around a bit, and there's a model which is called GPT-2, and can tell a lot of stories about unicorns. So it's a text completion model. You can enter a text here in bold. In a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprisingly to the researchers was that the fact that the unicorns spoke perfect English. And then this AI model, it will just continue the story. And it's super nice. You can play with it. It will tell you a lot of stories about unicorns. Here, it tells you the stories that researchers have found the mysterious, rare, and endangered Andean unicorn, also known as the llama antelope horse, which is living in a remote valley. But then the next question was, okay, this is nice. Everybody loves unicorns, but what does this thing know about crypto? And then the thing is, I think it was basically trained on the internet. And the internet is somehow full of Bitcoin and quantum. And this happens if you enter post-quantum crypto, and then it asks about Bitcoin and the idea of quantum crypto systems like quantum key distribution, the quantum resistor, and that it's not new crypto and security. And I was like, okay, what's going on here? Yeah? This is stupid. We need something better. So I got into this, and I played around with this. And also, word of warning from my side, these AIs can really suck you in. So I was playing with it. My girlfriend was coming home from getting a haircut. I was getting out of the room, was smiling. She was expecting a compliment. and it can talk. Yeah. Yeah, you have to see it. It's so smart. And yeah, this obviously was not so well received. Don't do this. Yeah, what can you do? So the model is kind of smart because it was trained on the internet, and it can understand English, but it can also be fine-tuned. And so I thought, okay, how can I fine-tune it? I played around with it a bit. So I started with a model that can generate IRCR fellows, but this is kind of boring and there are not too many of them. And then I thought, okay, maybe ePrint is a good source. So what you can do is, or what I did, I just downloaded all the abstracts from ePrint, 1969 to end of 2021. And then you can just fine tune the stuff in Google Colab, really easy. Thanks a lot to Google for making graphic cards available. And then I had the model and I put it into the cloud. There's a very nice, very fast implementation. And I always wanted to dabble a bit with JavaScript and fast API and all this new stuff, because the last time I did web development, there was PHP and like static HTML pages. And yeah, never bad to learn something new. And yeah, this is what came out of this. And I'm doing a live demo here. So this is the crypto abstract generator. And what you can put into it is a title and an abstract, and it will then continue and will write the abstract for you. And so I would like you to enjoy this, and I will also give you the link later. And so what you can do, you can just let it write an abstract. So here on new frequency records for F0, in this article, we give some new frequency records for F0 with new names. But now I got a bit stuck. But of course, we can also give it a hint what we want to see. So something obviously, so this paper should definitely be written.
See them, right? New Hope is better.
And we can just let the AI do it.
I can shoot like this.
So yeah, seems legit. And maybe NIST made a terrible mistake. And then what I also discovered is the AI learns. So it also noticed, there are these dollar signs and stuff like that in a paper. And if the title has a formula, then probably the abstract should have too. So we can apply the markup, I think. Come on.
Binary, sure.
Oh yeah, here it is. So, and maybe to wrap up, maybe we can do something nice. Maybe Peter, give me a keyword.
Well, I would go with side channels here, Chess. No, higher order masking.
Higher order masking.
Yeah, higher order masking.
Let's get inspired.
Blockchain.
So the model is really good on blockchain stuff because it was trained on the internet, and then it was made really smart with all the knowledge of IRCR, ePrint. But it retains some of this blockchain knowledge, and for it, crypto is still blockchain. So yeah, this is my contribution to the Rump session, and there's of course also now the question: what would be future work? What can we do with this? Of course, we could build a game, identify AI generated versus ePrint. And I have this here. So this is a paper that one of the chairs wrote, and I would like you to vote which one is the real.
wasn't me.
Yeah, the left one is the correct. So this might be a nice game to do. And then, of course, there's also the challenge to the audience, generate an abstract, get inspired, write the paper, and then get it accepted. I would love that. And of course, this approach can be extended. So for example, one thing that I thought of is just training a model for a single author. But of course, we need data. On the other hand, I think Amir would be a good target with all his papers. Yeah, I think we can make an AI out of his work. We could also do maybe an AI that does the flame war on the NIST mailing list for us. I tried a bit, but so far the results were just incomprehensible. And what we could also do is maybe an AI issue in the Journal of Cryptology, train an AI to write abstracts, train an AI to review them, and then train an AI to give the talk on YouTube. And it would be beautiful. The whole thing would just work without human intervention, and we could have coffee and beer. And yeah, if you want to play around with this, this is at cryptgen.com at the port 1337. It's running in the cloud, but clouds are expensive. The server may get overloaded. I'm working on it, probably try a bit later, and I hope it survives it. And yeah, with this, let's hope the AI is wrong in the end, because I asked it about the end of crypto. And basically the answer was that cryptographers are dying and will be replaced by machine learning in our lifetime. So thank you for your attention and have fun.
So after this important contribution to the field of cryptology, it's going to be Gustavo who has the challenge of taking the next slot in this Rump session.
Yeah, it's a little bit hard, but at least I will try to enjoy for some people. So I just say AI. Yeah. I'm going to say a lot during the talk, even having no relation with it. Just for you guys to be drunk. So, okay, so this is like a misogyny club. The original, it's Jonathan and Kyrene. They're like creating this misogyny club, which is the first rule we should not talk about, but we are talking about. And since they don't care about like implementations, I was like, they're not here. And then I was like, hey, do you want me to sponsor this? They're like, yeah, go ahead. I was like, thank you. Can I make it fun? You can try. Well, AI. So then, I mean, the question is, if you're like on Twitter, you know that misogynists might be dead, especially after some Belgian people. Just attack them. So, but yeah, I even tweet this one time, like stop, like because there was the first paper and then the second paper, and someone like, we can just start it from random curves. Nope, you cannot. But the thing is misogynist really dead, AI? In fact, not today. We still have like some things to break if you want. If you're Belgian, we have like the next weekend coming up, so you can just attack this, and then, well, you have a nice publication. But if you are not like in the attacking side or you are in the attacking side, you can join their misogyny club. It's wait, AI. So it's the misogyny club. It's a bi-weekly virtual seminar. So you can just even use as a background noise. Like, for example, you're like doing some, let's say, challenge during your conference, AI. And then if you really wanted, you just reach them by email. You can follow them on Twitter. They even have like a really nice page, which is just a static page with the next talks. And they usually have this like on, well, on Zoom. So everyone knows those on Zoom. So it's this. So thank you for this and AI. And then we have the next one.
All right. Then next up is Gaëtan. It was yours.
Thanks. So I'm delighted to learn that this talk is supposed to be funny. So to be more funny, it will be very serious. There will be no AI there, so no cryptology. We'll just speak about our chess artifact that many of you submitted this year. So this is a project that we launched with some people from UC Louvain University, but that we would like to open to anybody here. The fact that when you write a nice paper to chess, maybe people want to use it. You wrote very nice code, but nobody can understand it because, of course, you write the code for yourself and not for anybody else, even if it's for an artifact. We all know that. So maybe today we could do something better for that, just like OpenSSL. No, kidding, LibreSSL. Maybe better than OpenSSL, and do something serious about embedded implementation for cryptography that we could share among this whole community. So our project is try to gather open source implementation, high quality ones that you can use in real industrial products or homemade products if you want to. And the idea would be to make it done by the people who know that the best to achieve the best security, that is the researchers. But of course, we all know that researchers, end of PhD students, postdocs, and so on, are not always the best at writing industrial quality code. So the idea is to make a kind of peering by starting a non-profit foundation that would fund researchers to write industry quality code for their scientific contributions. So that's one of the proposals. And the other proposal is to be able to train all the people to use that code. So how could we do that? First, gather help from the community to identify what could be cool and interesting contribution to do. Maybe ask AI to do it if you're out of ideas. Then you ask a very senior scientific council to validate these decisions. Then you try to find someone who wants to work on this, hire him from an internship, try to gather good supervision and guidelines for high quality implementations. You make it open source. Everybody likes a challenge, so you can challenge and break it or improve it. And then finally, we need some people to fund all of this. So we will look for sponsors who will pay for the internship, but then receive like permissive license. And then in the end, we will want to maintain these implementations if people are interested. So this is all super nice project, but concretely, what are we doing now? So we have in the works start project, which is a higher order masked AES implementation hardware. Stay tuned for CTF coming soon. We have a side channel evaluation library. We want it to be efficient, usable, and so on. This is already online, full documentation. You can look at it. And we also have a poster somewhere. And then in the longer term, we look for other project proposals, sponsors, that's already know. And we will try to put together a training on all of these topics for people to use the implementations. So thank you for listening. Don't hesitate to call and talk to us, so to me, or either look at our websites. There will be some announcements soon. Thank you.
All right, and the next talk is about beep beep.
Yeah. Hi, I'm Shahram, and unfortunately, I don't know how to make full presentations. I'm just here to announce our recent design. It's beep beep. It's joint work with Jans Berger and Johan Dama from Radboud and Christoph Dubroniak and Santosh Ghosh from Intel Labs. Recently, Intel introduced CQ. It's a memory safety mechanism, and it is used for preventing some of physical attacks on CPU architectures. And it heavily relies on ultra-low latency cryptographic primitives, such as a tweakable block cipher with special requirements. It has 24 bits of block size, 40 bits of tweak size, and more especially, it has to provide decryption in 2 or 3 cycles of 4 to 5 gigahertz in Intel's technology. These requirements makes this design very challenging because with all these restrictions, it has to provide cryptographic security in the same level as typical tweakable block ciphers, and we accept this challenge and designed BitBit. Its name is taken from this character that you may know from the cartoon Pip Pip and Coyote. Its general structure is shown in this picture. It has 11 rounds in data pass, and there are 3 shell rounds followed by 5 core rounds, and then again 3 shell rounds. It uses 12 round keys, which is derived from a master key of 256 bits and a tweak. In the data pass rounds, we use S boxes. In the S boxes, which is shown in this picture, it is possible to be implemented in gate sets of 4 in the basis of 2-bit NANDs or NORs, and depending on your library, you can make it more simple. For diffusion, we use different type of linear layers, which can be a bit permutation in the shell rounds, or in the core rounds, we use XOR of 3 bits for each output bit. And in the tweak pass round, we use 53 bits of state size. It's based on a Xi function of the same size, and again, linear layer can be different depending on the runtime. We claim it has 96 bits of security in all of these adversary models, and this claim is based on an extensive cryptanalysis using most known attacks, and also we use some customized attacks for small sized block ciphers. And we also verified the Markov cipher theory. We implemented in the unrolled architecture, it can be implemented in about latency of 600 picoseconds in the Intel's 10 nanometer technology, and in the pipeline architecture, which will be the use case, it can be implemented in 3 cycles of 4.5 gigahertz. Finally, we are looking for some coyotes to catch a Pip Pip. If you are interested, please have a look on it, and if you can cryptanalyze it. We are looking forward to it. Thank you.
Thank you. And now we'll learn how to break RSA.
Space key. Just space. Okay.
Hi, everyone. I was hoping to get the first slot in this session because I have one of the very few serious topics here. But this is about a topic that was really surprising to us when we discovered this last year. And I'm trusting that despite the wine and the beer, there's still enough scientists in you to enjoy this topic. So it's about brute forcing private RSA keys. Now, with side channel attacks, typically one recovers a part of the key, but not always everything. And the figure here shows that in a graph, you can immediately see the bits that are probably a 0 and the bits that are probably a 1, but there's always this middle section. And this can be a lot more than you can actually brute force. So the big question is, how do we find the missing bits? And there's existing methods, but these require missing bits to be grouped, for instance, all in the left key half. So when we try to do brute forcing, we run into the problem that RSA is a relatively slow algorithm, and typically a full private key operation takes about a millisecond on standard hardware. So that means that brute forcing more than 30 bits becomes troublesome, and a high degree of leakage confidence is needed to complete the attack. So how do we solve this? And there's a couple of formulas here, so I hope you can still stand with me. So there's 3 steps. The first and second step, you do that once, and the third step, you're going to repeat endlessly. So first you initialize your crypto. You have a public key and a private key. You don't know the private exponent D, but you do know the modulus N and the public exponent E. So you choose a signature S, and then you compute message M as S to the power E mod M. And of course, S can be recomputed if you knew the private exponent, but we don't. So the next thing that we're going to do is to prepare a signature table. And what we'll do is to compute signatures for consecutive values of D without knowing D. How can we do that? So the first signature that we compute is S1, which is m to the power D plus 1, which is actually equal to S times S mod n. And that is a value that we have. So we can actually compute S1. We can also compute S2, and we can continue doing that. So we can create a very big table with consecutive signatures for consecutive private exponent values, even while we don't know the private exponent yet. So this is a step we do only once. And then we start the enumeration process, which can be repeated billions of times. So we generate candidate values, D prime, for the private exponent D that we don't know. And here we enumerate the most significant bits, and we set the least significant bits all to 1. Then we compute S prime as m to the power D prime mod n. And we're going to check whether S prime equals any value in the signature table. If it does, in case of a match with the signature at position I, we actually learn the correct value of the private exponent D as D prime minus I. So this is a process that will make the brute forcing much easier. So we replace the exhaustive key testing by table lookups. And the brute force problem is now reduced with the table size. And with some additional tricks, we can now brute force up to 70 randomly distributed bits just in standard hardware. With a more advanced computer, we can do more, but 70 bits is already quite impressive. Now, before I walk off, there's one little secret I wanted to share with you. Probably only very few of you know that already. Behind this auditorium, there's an exposition space where the sponsors are showing their demos and knowledge, their wisdom. Only very few know that, because today I've seen maybe a dozen of you over there. So I'm going to invite all of you to come over to tomorrow during the coffee breaks. And with every coffee break, the first person to visit our booth will get this book. This is the Hardware Hacking Handbook, written by Colin and Jasper. Thank you.
Leakage. Victor.
Hi, everybody. So when I present you my last research work that I made on Saturday on the train for Leuven, called Title Attacks on Bread. So what's the starting point? It's this famous work from Daniel Jenkins and al. Called the Pita bread attack. And actually, what is the attack? So you hide a portable electromagnetic side channel attack setup in a Pita bread. You bring your Pita bread to a meeting where your victim is attending, and you put the Pita bread in the middle of the meeting table. So you send an encrypted email to your victim, and then you record the EM activity of the victim's laptop during email decryption. And so you analyze the SEH traces and extract RSA private key. So you can see this picture from original article. But what is the main attack requirements? You have to be in a region of the world where it's normal to bring a pita bread to a meeting. And from Wikipedia, pita bread is common in Mediterranean, Middle East, and neighboring areas. So what about other places in the world? So that's the first contribution of my work, how to adapt the initial attack scenario to other places in the world. So let's consider several use cases. First, India. What's the most famous bread in India? It's naan. Huh? It's really good. So the Jenkins et al. SCS setup fits in a naan. So it's okay. The attack scales to India. So let's move to Poland. What's the most famous bread in Poland? It's bagel. And once again, the SCS setup fits in the bagel bread. Just take caution about the bagel hole. Huh? And so the attack scales to Poland. And it also works in New York. Next use case, Mexico. So Mexico, tortilla. Tortilla is like thinner, but it can fit. So the attack also scales to Mexico. Another use case, Italy. Italy, you have several choices. Ciabatta, focaccia. Okay, it works. And then France. What's the most famous bread is France? It's a baguette, the French baguette. And it doesn't fit, you know, the antenna, the EM antenna doesn't fit in the French baguette, so it doesn't work in France. So, second contribution of this work, you know that any SE attack paper should always propose a countermeasure. Like you propose a new attack, so a new solution. So new countermeasure for this attack is like organize the meetings in France and you refuse any attendee with non-local bread. So it's an only baguette meeting. So yeah, thanks for your attention. And if you have any question, go to the Clarence battery.
Thank you very much. Now, Mike, take the mic.
So, continuing the trend of non-funny talks in the funny section. So glow stick. So this is a toy algorithm that the goal is to take these lattice chems and then see how small can you possibly make them if you throw away, you know, all requirements other than size, right? So CCA security, we don't need this high speed, we don't need this side channel. Even the requirement that it actually works, we throw away. It's allowed to fail, you know, a few times in a million because we're just going to bolt this to TLS so you can try again. This, you know, you could imagine deploying this as a countermeasure against like store and decrypt later, or somebody having a surprise quantum computer and you want to make this a little bit harder for them, but we're imagining this is hybridized with ECC or something, right? And the goal here is to develop ideas that could be used for real world systems eventually, not to actually itself be a real world system. So how do you do one of these chems, right? So you have a ring and then there's a random element A in the ring. Alice and Bob have small values S and T. They send each other AS and AT rounded, and then they both can compute AST, right? So just stepping through what I ended up finding for the smallest possible things here. So R is the n-true ring. Thanks to the round 5 team for discussions on this. The secret is a fixed weight ternary or possibly some other fixed weight thing that maximizes entropy. Usually that's ternary. Instead of sending a seed, well, you're insane if you want to try to use something like this without hybridizing it with something classical. So this is just Alice's ephemeral ECC key is also the seed. There's a problem with n-true rings that you can evaluate at 1. So we'll just nix that by setting A so that it evaluates to 0 at 1. And then that property also carries over to AS. So AS of 1 is also 0. And so you can round it so that it's still 0. And then you've you know, avoided that problem. But then the real key is how do you do the reconciliation, right? Because the better reconciliation you can do, the more noise you can tolerate, the more you can round everything before all of this falls apart. And of course, the more bits you round off of these messages, the fewer you actually have to send and the higher security you get. So that's the main lever that you have. So there's 2 layers of this. So one of them is, well, you just do the usual thing of like send the second highest bit and then the key is the highest bit. Maybe you can get a little bit extra if you do it in E8 instead of Z8, but same idea. And then maybe more importantly, you put on a giant error correcting code. So this is actually maybe the part that I could use the most help on, or where the most improvement is possible, maybe, which is that LDPC codes and other sort of, you know, communications, noisy channel error correcting codes are a bit of a dark art, and I'm not a practitioner of that art. So if somebody is, hit me up. But so anyway, so you can then use maximum likelihood decoding to find the most likely key. You know, Alice finds the most likely key given Bob's hints and then what she's computed. So if you go through Martin Albrecht's estimator to try to find parameters for this that mostly work, then there are some like especially toy instances that are like, hey, break this so that we can find out, you know, how many bits they actually are secure. And then the quote unquote serious instances, For class 1, you can get under half a kilobyte of key plus ciphertext. So it's you know, about a third the size of Kyber or something like that. Yeah, so there's a bunch of possibilities that we could improve on here. You know, are there attacks against all these insane things that I'm doing? Can somebody improve these codes? And like, are there other tricks that we should use? Anyway, so thanks for listening to my drunken 11 p.m. ramble. Thanks also to Leo Ducas for help on this.
Thank you very much. And then we have Gustavo again. We made sure that he has to walk twice to the stage in the program. So there you go. Stage is all yours.
Oh, look, it's me again. Yay. I really want the prize. Just give to me. Okay. Yay. Okay. Anyway, AI. For who doesn't know why I'm saying AI, like people in the internet, it's because there is a group here. Every time that they say AI, they needed to drink. You didn't drink. Yeah, thank you. Okay, so now it's a little bit more serious because we have like this big Latin American, but if you don't know Latin Americans, we are not exactly known to do like crypto. So we have like a lot of people outside of Latin America, which it's basically a lot of, I really like how Peter is running, okay? It's a beer. Oh yeah, he wants to challenge it. Okay, Peter. Woo. Yeah, so let's just see. You drink AI. Yeah, nice. Yeah. So what are we? We are like just a community of Latin Americans because we face similar problems. Everyone that it's from like any place in Latin America or Caribbean, and usually we have like this community that we are like trying to build to teach people that it's outside of this area, because English, it's not our main language, as you might know, because my accent, or like if you talk with any person that it's not from like English speaking country and it's from Latin America, they have like a really strong accent. Sorry. Yeah, see, so AI. I'm just verifying if he's like, oh, there is a, thank you. And who are we? We are like PhD students, postdocs, professor, researchers. Researchers, it's nice. It's the thing that when we're like, you don't know if you're like in academia or in the industry and you just do research. We usually have like bi-weekly meetings again, like, so same thing as before. We sometimes do workshops online because it's easier. And we have like a Slack. If you want to do this, just go point this and you are going to our Slack. Usually there is like a lot of conversations and translation of the material to the like Portuguese or Spanish. And it's who are the people. And that's why I can stay like longer here, because there is one of these guys, which is the chair, and he's laughing like, hey, I'm laughing. AI.
Just to you.
By problems, you mean visas, right? Yeah, for problems, I say visas, and even like sometimes the language, it's a barrier. So if you have been in crypto, you have seen the same talk with like more slides about visa. And then we have much more people. We have like 80 members. So it's 80 members, and we are basically across the globe. We have people here in Europe, we have people in New York, we have people in US. I say that New York is different because like they have like even different brands from the previous talk. So we try to do something like promote this, try to inform that the students, they can have like stipends. which sometimes we don't know that have stipends. And if you are like from Latin America, you have no idea sometimes that you can travel. So if you are like watching this, or if you know someone, just please let us know, and then it's going to be nice. And one more time, AI. And then this is like, we have like a Twitter account again. We have a website, which is Crypto Latino. We have like, sometimes like we promote summer school conference and workshops. And usually we have like a lot of material in the Slack. Also in the website, we have like something. And one thing that I forget to joke about is that, wait, we have a lot of like people from Spanish-speaking countries, but because of the Brazilians, which is like Diego, Gustavo, and well, me and Fabio, everyone needed to speak in English because we don't speak Spanish. So it's amazing. Every meeting, they like start speaking Spanish. I was like, sorry guys, I don't speak. So this is like what I'm saying today, and there's like AI. AI.
Cheers to that.
So before I start, how many were in Atlanta in 2019? Raise of hands. All right. So I did a lot of work for 2019 together with the other general chairs. Thank you very much. By the way, for your talk, so I'm Vincent Mooney, right? My father, go back 200 years, is from Ireland. My mother's from Cuba. And I go to the Hispanic faculty meetings at Georgia Tech. Half the time I get stopped at the entrance. Why are you here? Because yo no hablo inglés con acento. Yo hablo español perfectamente, si quieres hablar. Bueno. So I could join your meetings and understand the Spanish. So I wanted to start with a serious concern. There's a lot of focus on quantum computing, and I've said these comments at dinner and with other folks. Look, to measure a quantum bit, this is serious. There's an issue with the Heisenberg uncertainty principle, which means that the measurement process disturbs the quantum state. So look, I'm not against post-quantum crypto. I think we should do it, and it'll have a high impact. But there's a serious issue in the community of quantum computing, which is noise. So I put the picture there, and the issue is they're doing so much to deal with noise, it's hard to get the actual quantum state. So I just put that as a canary in the coal mine. Another concern, this is partly serious, elliptic curves and weak keys. We know with DES, there's a bunch of keys you can't use in DES, right? Are there keys in elliptic curve, right? Because industry is moving towards elliptic curves because they're much easier to compute than RSA. But are there a bunch of weak keys? Now, the third comment, I wanted to ask all of you to talk to me over the next few days, because if you go back to the title slide, I was asked to be the director of the on-campus Master of Cybersecurity for Cyber Physical Systems. So I had some meetings and I said, okay, what is a Master of Science degree? What is a Master of Arts degree? Traditionally, science would be, you have mathematical models that predict the physics or the biology or the chemistry. Arts, there's no pure mathematical model, it's practice, right? Master of Business, being expert in what works in practice for economics. I live in Atlanta next to Emory. They have a Master's of Public Health degree. There's a Master of Engineering degree, some universities are starting. At Georgia Tech, we started the Master of Cybersecurity degree. So I had a recent meeting and one of the professors said we should teach control theory as a core class in the Masters of Cybersecurity, you know, pole zero notation, et cetera. And I said, well, if you're going to include control theory as a fundamental concept in cybersecurity, and by the way, I think Chess has maybe one paper in control theory over the past 5-10 years. So
The point is, maybe I said all the electrical engineering courses and computer science courses should be considered cybersecurity courses. So of course, no one agreed with that. But what does it mean to have a master's of cybersecurity? It's a serious question. I'm interested in feedback during this week. Just come talk to me, and thank you very much.
Thank you. Now, for the last talk, we need a short moment of setup, but trust me, it's going to be worth it.
Yeah, we need help from the Incredibles there. Yeah.
We need to help from the Incredibles, exactly.
We're destroying the equipment here. Let me put this back on. Yeah, so like this. Maybe put back on. No. You destroyed it. I can't fix it. That's maybe refixed. Okay. Maybe yeah, but not over here. Okay, good. Yeah. You said, bring.
Yes, I'll take that in a second if that's okay.
Yeah, go.
Okay. So yeah, my name is Antoine Pernal, or Turn for short. So please join the rest of the world in calling me Turn instead of the name that's up there. And so I'm from COSIC at KU Leuven, as you may have seen by the yellow T-shirt. And that means I'm a local. And that means I get an extra privilege, which is I can take something like this to an academic conference without having to explain to a confused airport officer, like, why are you bringing the guitar to a chess tournament, right? So. And for this, I will get some help from.
You get help from me, yeah.
Right. Okay. But I have some slides first. Can I?
You can go.
Yeah. Okay. All right. Okay.
It's very few slides, though.
Yeah. So with this privilege, I'm gonna play in keeping with the tradition of serious talks. I'm going to play a silly song, but I am. Yeah. There's one problem. And that's that, you in the audience are very skilled and you're kind of good with the side channels. And I don't want to reveal what the next sentence in the song is. So I need to up the game a little bit. So your skills preclude me from, rhyming with differential hour analysis. Because, with your domain expertise, you will immediately know, what I'll be rhyming with. So I'll try to keep as much as possible a secret from you. But there's one public input, and that's those two phrases. And, if you feel like it, maybe you can join, maybe not, we'll see. And so now the mic bearer will join me, which is fantastic. So. Can you hold it in front of the hole? Yeah. Okay. All right. Don't forget the feathers. I'm kidding. Drop your insecurity. Join us in security. Brute force a 40-bit key and butterfly an NTT. Use DPA to break SHA-3. Protect the world from NFTs. Are you still okay? Okay, you're comfortable. Okay. Use a proper RNG. Quantify anonymity. Generate AI abstracts for me. Man in the middle, get the key. Drop your insecurity. Join us in security. Okay, second verse. Submit work on hot CLP or hot grab more informally. Operate homomorphically. Use the white trail strategy. Symmetric key, you got it? Reverse engineer what's proprietary. Track COVID with DP3T. Get time with RDTSC and join the Artifact Evaluation Committee. Drop your insecurity. Join us in security. There's more. Get mad at reviewer B and maximize the entropy. Implement it in MPC with differential privacy. Break white sorry, I'm gonna do that. Break white box cryptography. Invent a cryptocurrency. Use TLS 1.3 and go to metaphor with me. Drop your insecurity. Join us in security. And this is the last one, I promise, but we're gonna make it count, okay? Timestamp with a Merkle tree. Accelerate TFHE. Evict lines from the LLC. Inject the fault transiently. Shamir, share your secrets with me. Rowhammer breaks integrity. Unroll to get low latency. Cryptanalyze isogenous. Timestamp to the Merkle tree. Accelerate TFHE. Evict lines from the LLC. Inject the fault transiently. Shamir, share your secrets with me. Rowhammer breaks integrity. Unroll to get low latency. Cryptanalyze isogenous. Drop your insecurity. Join us in security. Now you! Drop your insecurity. Join us in security.
So this was the last talk of the Rump session, which leaves us with a very, very responsible task, namely to hand out the RSA, the Rump Session Award. Do we need to vote? I think it's a very tough vote. So I think actually, can we just decide this by democracy between the two of us?
Yes.
Yeah, I think we can, right?
Yes.
So, no, well, okay. So we do a vote. We do a vote between two things. So there was two things that really, I think, stood out. There was crypto AI and there was insecurity. So we do this by clapping. Who is for crypto AI to get the RSA? All right. Who is for insecurity to get? Yeah. That's what I thought.
Thomas, this was a tough competition. I told you from the beginning. So, John, can you please come up?
I should say, handing this to someone from Belgium is kind of ridiculous, but also it has a real advantage that it's easy to transport, right? So, congratulations. Thanks. All right, this concludes the Rump session. And we talked to the people at the bar before. Not sure exactly, there might still be drinks. You might want to run. Thank you very much.